All right, so we have one thing to download today. Where are we? What is today? Here we go. So Google Sheets 2. So the idea here, so go ahead and get that downloaded and get it open. The idea here is we're having kind of one more day talking about working with internet resources through Excel. And today, we're going to use Google Sheets. Now, we're not using Google Sheets as a replacement for Excel. In other words, Google Sheets is a lot like Excel. As a student asked me earlier today, yeah, you put in formulas and functions and everything. You know, you can do pivot tables, and did you know that? You can do solver in Google Sheets. There's a lot of stuff you can do. But we're going to use it basically just as a data repository. There's a question here? I just uploaded this at the end of the last class. Some of the stuff we did in the last period, I thought, you know what, we should start with this stuff already done. So kind of halfway through, I said, let's just save this as a point and we'll move from there. So here's a nice thing, is that Google has this web interface to be able to accept information into a Google worksheet. And it's a way for us to be able to both push data up to that central repository and pull it down. So it's kind of like a way that without really having to set anything up, we could use it like a database to be able to store some information where we could collect it from several different places and then download it and then be able to work with it. As it turns out, we could, through VBA, we could actually authenticate with Google Sheets, and we could, like say, I want to, manipulate this sheet, add a row here, put this formula in here, put a chart here. We can do all of that through Google Sheets, but it's really not in the same way. It's having to work with the Google Sheets API, and it is much more complex than the stuff that we've done so far. If you're thinking, hey, I want to be able to automate Google Sheets, probably VBA is not the right way to do it. You can do it that way. You're probably better off learning the native way to automate Google Sheets, which is Google Apps Script. But it can be very handy for us to be able to say, I want to push some data up there and then pull some data back down. So, how many of you are already familiar at some level with working with Google Forms? You say, you know what, I've made a Google form for at least something. See your hands up here. It looks like maybe about half. How many of you are going Google what? Is there? So a few of you, no one willing to admit it apparently, but have some experience with it. Okay, so here's the idea, is that we can set up a Google form to be able to accept information into a Google Sheet. Now, you could create your own form to do that, but I have already created one that is tied to these identifiers that you have in the workbook. So let's just go ahead and take a look at it real quick. Let me go ahead and open up Google Forms. Should have already been logged in here. Stand by for a moment. My Drive. All right, so let me come down here to the folder I put it in, ISD, Information Systems Department. I've got one for IS 520, and VBA Form 3. It is an untitled form. That's a great thing to have. So here's the form. Here's the idea. What I'd like to do, and we've got so far, wow, I made this form like a couple hours ago. I already have 3,000 responses, almost 3,600 responses. Here's the idea. So we can take information in through this form, and it will put it into the Google Sheet. What I'm actually interested in, I'll call this Excel Random Evaluator. Here's EVAL, eval, A-D-O-R. Didn't I spell evaluator? Maybe evaluator is not a real word. Okay. Here's the idea. I would like to get a sense for I want to know if there's some bias in Excel's random number generator. I mean, does Excel really generate numbers randomly? No. No computer generates numbers randomly. We have complex algorithms to try to make things look random. But I'm curious to know, is there systematic bias in Excel's random number generator? Here's what we're going to do. I'm going to say, listen, we are going to generate 20 random numbers. Each of you will generate 20 random numbers using Excel. Just use the rand between function. In fact, it's already built into the worksheet. And then you'll take those, just ones and zeros. Just give me ones and zeros, give me 20 of them, randomly chosen. And then you're going to push those 20 values that you selected up into this form. So you're going to give me your name, and then you're going to give me a 1 or a 0 in each one of these locations. 1 or a 0, 1 or a 0, 1 or a 0. So in fact, let me go ahead and I'm going to go ahead and fill one of these out. Student me, whoops, I need to be editing, sorry. Let's go back to student. So I'll click on the all-seeing eye here, and that should let us preview the form. All right, so this will be me, gov. Now, ultimately, I want this to be a 1 or a 0, but just so we can see the data a little bit better, I'm going to put in an 8s. I'm going to put 8s in all of these. Tab 8. And we've got 20 of them. Okay. So I put in my name, I put in these values. Now, I'm not going to have you type them in. The whole point is we want to have Excel push this data up to the form automatically. So now I'm going to go ahead and submit this. And now it says, great, your thing has been submitted. You're ready to do another response. Yeah, let me come back. I will in a minute, but let me come back here, look at my responses, and come to the worksheet. I should be able to come to the very bottom of this and see the value I just put in. I think. Control down arrow. So it looks like Marcus got another one in there. Somebody else put in some other values. Maybe that was me, I don't know. But here then is the values that I just put in. So it got sit there into the worksheet. So I'm guessing that you've had some experience with Google Sheets and you get that's how it works, or Google Forms. You get that's how it works. You make a form, those values come into the worksheet. Now, you're going to notice that when I hit submit with all those values, here's the URL that it went to. There's some URL with long code in here that identifies the form that I'm working with. But there's nothing in that URL that shows me the values that I just submitted. All those values are in the body of the request. They're not in the header. They're not in the URL that I requested here. Now, so this gets a little bit into the hypertext transfer protocol, HTTP, or HTTPS, just a secure version of that protocol. There are about 4 different ways that we make requests from a browser to a server. 2 of them by far dominate all the traffic that happens between web browser and web server. And this is called a method. So how do we ask for the data? There's a method that we can say, here's the URL that I'm asking for, but what's the method I'm using? Am I going to use get? I'm just trying to get some data. Or am I going to use the post method, which says I'm going to try to push some data up to the website? Now, according to the specification, if I'm making a request that only brings data back from the server, it doesn't change what's on the server, then I'm supposed to use a protocol called get. I'm just getting data, not the protocol, but I'm using a method called get. But if what I'm doing is going to change the data that's on the server, I should use post. Now, what did we do when we submitted this form? Did we change what data was on the server, or did we just ask for some data to come back? Which of those 2? Which one? No. It's either we just asked for data or the request made a change on the server. Yeah, it made a change, right? It recorded our data. And so as it should, it uses the post protocol. In the post protocol, all that information is not put in the URL, it's put in the body of the request. So you don't see it in the URL. And the whole reason is we don't want someone copying a URL that changes the data on the server and giving it to their buddy to follow. You know, if they copy that URL, it's not going to change the data. That's what the post protocol does. It hides the parameters that we're sending to change on the server. There's no reason that we couldn't use the get protocol and still change stuff on the server. In fact, the nice thing about the get protocol is that you can see everything that's being passed to the server as part of the URL. So that's what I'm going to do next. I'm going to go back, make another response, and I'm going to put, now this time I'll put 9 in, I guess. Instead of 8, gov. Put a bunch of 9s in here. 9. Remember, ultimately, it's going to be a 1 or a 0, indicating heads or tails. Now, instead of hitting submit, I'm going to click on one of these. It doesn't really matter which one. I'm going to right-click, and I'm going to choose inspect. I want to go look at the source of this page. Now, I clicked on something inside that form. A form has to contain whatever I'm going to be sending off to the server, information I'm sending off to the server. So what I'm going to do is I'm just going to scroll up until I find the form. Here it is. Form, action. There's the URL that we're sending it to, but you'll notice right here the method is post. I am going to change this to get. I just changed the form that got downloaded to my browser. I'm changing it. Great. I'll close that. And now when I hit submit, the same thing happened. What's wrong with that? So I did something. Maybe I had to hit enter there. Let's try that again. That was a little bit bad. Student, your answer is me. FGov. What does the F stand for? You don't want to know. Okay. I'm going to try again. I'm going to inspect. I'm going to scroll up till I find the form and change the method. Did I pass it? Ah, there it is. To get. Okay, maybe I didn't hit enter on it last time. I'll leave that open just in case. And now I will submit. There we go. So now, in addition to what's showing up here, I'm seeing entry with this number here, 3496 is the last part, is FGov. I go over a little bit more. What do I have here? I got another entry with this long number is 9. Another entry is 9. So when I submit with the get method, all the parameters that I had in the form show up as a part of the URL. The nice thing is I can use that to find out what the names of these parameters are. So I know that to be able to receive one of those coin flips, it's expecting to put it in a place called entry.9588175995. And I can use that information now to formulate this request. In fact, watch this. I could take this whole URL here, and I could just paste it in, hit enter, and it tells me your response has been recorded. Did it really record it? Yeah, it really did. So I'll come down here to the end, and we should see 3 sets of me doing 9s, 2 of them which say FGov, and someone saying gov9. So because that's in the get, just sending that, refreshing that URL or sending it again, we'll submit that information again. So now that's going to allow me to just format a URL that has those values in it, and we should be able to send that information up to the server. Even if I was going to send it by post instead of by get, this little trick of changing it to get here allows me to see the parameters so I know what they're called. Quite easily. I can track them down other ways, but that's the easiest way. Easiest way that I know of anyway. Okay, so now we'll come back here and look at the worksheet that we downloaded. And what we're going to see is that here's the part of the URL, that right up to here where it says form response, the last character is B1AA. Let's just see if it looks exactly the same. Come back here. Yeah, B1AA, form response, question mark. And then entry 25, starts with 25 and ends with 96. Entry 2596, question mark, and then here's entry that starts with 25 and ends with 96 equals gov, whatever I've put right here. So now we can just use all of this information that we have here, which is just randomly picking a number between 0 and 1, and then it builds it into these little parts of the URL, and then this URL down here just collects all of those up. It just takes C2 and concatenates everything from H4 to, it starts with this part right here, and then concatenates all of these into it, and that gives us a URL. Now this URL changes every time I refresh the page. Let me hit F9. So recalculating that page just gives a different random pull on all those numbers. And so now I can take this URL and paste it in, and it won't just be all those 9s. It'll be the values that we just calculated there in Excel. Come back and look at them. I should have something that says gov with 1s and 0s instead of just a bunch of 9s. All right. So if we could figure out some way to be able to just make the request to the server with this URL, it should push that information onto the Google Sheet. And in fact, we could do this just by sending our Internet Explorer object there. But the Internet Explorer object is really slow, comparatively. I'd like to avoid it if possible. So I'm going to introduce you to a new control, or a new way to interact with a web server. We've seen 2 ways so far, haven't we? We've seen the Internet Explorer object, which is nice because it maintains a session. We can go find a place, actually put a value in it, find the submit button, hit submit. we've seen the web query wizard, which is, we can actually use the web query wizard for this, but it does a pretty good job of finding the data, bringing it into Excel, but it's limited by two things. What are the two main limitations of web query wizard? Number one, password protected is going to make it difficult, very difficult, maybe impossible. And number two, we're limited just to be able to see what's on the page. If what we're looking for is in the HTML source, we can't get at it. So this one kind of comes between those two. So let's go ahead and look at the code behind this form. Oh, not this one. This is the encryption. We'll look at this later. That's mod encrypt. We want mod module 1. So just like with the Internet Explorer object, it's not built into Excel. It's a part of Windows. And so we have to add a reference to this. This is called the Microsoft XML HTTP object. And so we have to add a reference to Microsoft XML 6.0, which I've already done on this workbook, so you don't have to do it. But it's the same thing, right? Tools, references, and then here's the name of it. Apparently I put an underscore there when I should have put a closing parenthesis. They're right next to each other. Okay. So now we are declaring an object of this type. This is the object that knows how to interact with a web server. Now, this is non-visual. Nice thing about Internet Explorer is that it's visual. You can actually see what page it's on. Working with the Microsoft XML HTTP object, there's no way to see it visually. You can see the source, the HTML, but it never will render for you automatically. If you wanted to make it render, you could save it to a file and point a local browser at that file to see how it renders. But this, of course, this line here just creates an object that's allowed to point at that, creates a variable that's allowed to point at that kind of object. We're also declaring a URL variable as a string. Here's where we're actually creating an instance of the Microsoft XML HTTP object. And we're binding it on to our variable. Here, I'm giving it a URL to pull from. And now, here's where I'm actually using it. I've got two statements here. The first one just kind of opens the connection. It really doesn't start to communicate with the server. It just says we're getting ready to work with this with a web server. What method are we going to use? We're going to use the get method. What's the URL? It's going to be whatever URL we've specified. And then this says, is it a background query? And if we say it's false, that means it's not a background query. We're going to wait until the data comes back before we move on. So we don't have to say wait for load. This thing is designed to wait for it to load. And then the send is what actually then sends that information along. And now I'm just going to print the response. So this should just get whatever information comes back from byu.edu and print it into the immediate window. There it is. It's probably not quite big enough to hold, immediate window is probably not quite big enough to hold all of this, but do we see something that we recognize as being on the BYU homepage? Academic calendar. That looks pretty good. BYU academic calendar class. So this is just information that came back from it. Nice thing about this, it's really, really fast. The bad thing about it is there's nothing built into it to maintain a session. So you can't really log in and then keep track of that session while you're working with this control. You can, but it's really complicated to keep track of all the stuff you have to keep track of to make that work. So we'll use this for things that we don't have to log in for. Okay, so now I think I'm ready to push some data up to the server, to do it through VBA. So sub push data. In fact, I should have just copied the whole sub-procedure. I'm going to copy everything out of this sub-procedure and plop into my new sub-procedure. So we'll dim this, we'll make a URL. The URL now is not going to be here. I'm going to pull it out of whatever cell that's in. Where is it? So this is on sheet 1 in cell C26. Range, sheet 1, exclamation point C26. Dot value. I guess I don't mind printing the response text here, at least while we're checking to make sure it works. We'll go ahead and run this, and that should now. Oh, I got a comma where I should have a period. Dot value. Oops. Object doesn't support something. Oh, it's not send 5, it's just send. And so here's, oh yeah, right here, submit another response. That looks pretty good. Let me change something to make it a little bit more unique. Instead of gov, let me put like a number at the end so I can see it happen, so I can see it in the data. I'll go ahead and run this again. Now I should be able to come look at my data and see that one. There it is. Gov 334, is that what it was? Yeah. So that's, the data is now getting in from Excel. That's pretty good. Okay, let's pause right here and just kind of take stock. With the stuff we've done so far, just show me how comfortable you are. 5, really comfortable. 1 or 0, really, really not comfortable. In terms of what we've done, I'm seeing some 2s, 3s, 4s, not a single 5 out there. Okay, so let's spend a little more time. Anyone who wants to give me some feeling about where they're not quite making the connection? Or should we just kind of move on with some more examples here? Question? So the question is, if I gave someone a link, could I make it so that it would show the text that I wanted it to instead of... Okay, let me see if I understand what you're talking about. So let me close this. Are you saying on what comes back, like right here? Can I control what this says? Yeah. The answer is no. Because what I'm doing here is I'm making a request to that server, and that server decides what to send back. And so I really don't have any control over this unless that server is configured to behave differently depending on what I sent to it. Which I do. I do have the link here. So the question is, if I sent this link to someone else, it wouldn't get the changes that I posted to the server, and the answer is this is not getting changes at all. This is saying, what do we want to send up there? And it's saying this. Into the first entry on that form, put gov 334. Into the second entry on that form, put a 1. Into the next entry, put a 0. This link is telling it what to put into the database, what to record on the back end. Got it? Okay, so here's then what I'd like to do. I would like to have you enter lots of data. In fact, what I'm going to do, let's make one more sub-procedure that does a loop and just calls this multiple times. I'm going to get rid of this debug.print. So push data, I'll make another one called push lots of data. Dim x as an integer for x equals 1 to 100. Next. Do events in there just for kicks. And I'll do a calculate. That should cause CALCU. That should cause all those random numbers to be recalculated. CALCU, calculate. There we go. And then I'm going to call push data. So it'll redo the random numbers. That will also regenerate the URL, and that'll just push that information up there. So when I run this, I should see it just start accepting those values. And I forgot to say print X, darn it. Control break. Oh, pause. I want to be able to see it happen, so debug.print X. There we go, 28, 29, 30. Presumably there are others of you who are pushing this data in. How many of you are actually pushing data in? Just a handful here. So maybe we'll bump that up to 1,000 or so instead of 100. But it does take a little while to run. It's like it's taking about a second per request. But now all that information should be now stored over there in my Google Sheet. So if I come back to my Google Sheet and look at the data, yeah, we've got, oh, I left my Gov 334 on there, but there they are. Let's see. I'm not scrolling. There we go. Page down. Not especially responsive, maybe because it's loading so much right now. Anyway, there we go. Looks like we've got quite a bit of data coming in. Am I going the wrong way? 6. Oh, yeah. That's new to put the, actually not a bad idea to put the up arrow down there by the bottom arrow, but there we go. Okay, so we're pushing all that data in. What I'd like to do now is actually back this off from being a get to being a post, just so you can see the difference. Because it turns out that web server can look at the data that's coming in and it can say, I was expecting this as a post. You gave it to me as a get, I'm going to ignore it. So it turns out that the Google server says, I don't care if you give this to me as a get or a post, I'll take it. But sometimes you actually have to send it as a post. So let's take a look at what it takes to send it as a post. To send this as a post, I need to have my information in 2 different parts. So let me do this. I'm going to change this so that it doesn't have the question mark on the end, because the question mark is what says, hey, we're getting started to show the other parameters at the end. So let me get rid of the question mark here. And instead, I'm going to put the question mark down here so that this URL still works. So I'll take C2, I will concatenate on a question mark, and then concatenate on the rest of it. So that should make this just the way it was before. The question mark's here, but it wasn't here. And this is exactly the way that I need it for post, because for post, I need to take the URL as one part. That's where I'm going to communicate, and then I send all the parameters as part of the body. So I'm going to copy just the concat part of this and put this here in C27 equals that concat. This then is just the body of the request. When I make a post request, instead of putting all the parameters as part of the URL, I put them in the body of the request. This is different. I'll show you how to do it here in just a minute. And so I have to have it separated into these 2 different parts. So this URL here in C26 is just everything specified to go as a get. This URL here, now I have 2, the initial URL in C2, and then all the parameters here in C27, which I can use to make that request separately. Okay, so let me come to here to where I say push data, and I'm just going to change this. Instead of the get protocol, I'm going to do the post protocol. And my URL, instead of being in C26, is going to be in C2. Is that where it is? Yeah, C2. That's the URL. But now to send the body, I got to send what's in C27. And that's actually what I send. And so send can take a parameter, and that's the parameter that I want to send. It's the body. So now instead of having all those parameters as part of the URL, the parameters will be part of the body that I'm sending. Truth is, it's been a while since I worked with this particular object to do a post request. So I hope this works. I'm going to go ahead and print the response to see if it looks like it worked okay. Oh, no, this one should be C27, thank you. Because C27 is where all the data elements are separated from the URL. So I have URL plus the data form here. All right, let me just run that and see if it looks like it took it. The question is, am I getting an error back? Or did it look good? Your response has been recorded, so that looks pretty good. I'm going to go ahead and change it to a different number, so I can just check to make sure that it's there. Gov 999. And I'll push it again. And it looks like it might be going in, but not recording. 1527. Yeah, we've got some others going in. So, what have I done wrong here? All right, I'm not sure what I have wrong here on the post protocol, but let me just go ahead and spin it back to the get protocol so that we can move on with the example. We'll just leave it as get for now, so I'll put this as 26, and I will not put anything in the body. It'll take me a little debugging to track that down. Okay. Next thing I'd like to do then is actually see what does it take to bring this data now from the workbook, the Excel Google Sheet, what is it? The Google Sheet, and bring it down into Excel. And so it turns out that to be able to get access to this worksheet, I have to be authenticated. Right? I've got to, I have to have shared this with whoever is going to use it. And as soon as we say, hey, we're going to try to work with VBA and authenticate against Google Sheets, it's possible, but it's really involved. The other way to get at this data is if I had this data published. So let's take a look. I'll just publish it as a public web page. So I'll choose File, Publish to the Web. And I don't want the entire document. I just want Form 1. Take it as a web page, or I could take it as comma-separated variables or whatever. I'll take it as a web page. And then I think I've already published it. So there would be a button here to say Publish to the Web. But that would give us this URL that would just be a public URL to be able to get at that data. So if I paste that URL in here, this should just be that data from the worksheet. It's thinking about bringing it. And there it is. You don't have to be logged in for this. Just with that URL, you should just be able to pull the data. And in fact, I have put that URL over in Learning Suite. So if you go back to Learning Suite, that's the download data link. If you follow that link, it will just show you that data in a web page. Question? Stand by for just a minute. Okay, so we're just trying to bring that data down. We now have a URL that's open and accessible that we can use to pull the data down. So let's see how to do it. Now you remember at the very beginning of the semester we talked about a tale of two web queries. There's the old legacy web query that was kind of really easy to use, made great code that we could work with, but wasn't as powerful as the new web query. But that old web query is a little harder to access. So what I did was I created some procedures that would just let you generate a web query through code. It uses the same web query tools, but it just uses a method called, or just a sub-procedure called create web query. And I mean, that's all it's really calling is this stuff right here. So you just have to give it a destination, a range where you want it to go, and a URL that you want it to go to. So let's do that. Let's do it. I am going to create a sheet just to hold the data. I think I'll name it data. And sub, I'll call this get form data. We'll say get web query. The range that I want is range data A1. The URL that I want is that URL from Google. And this should just use the web query wizard to pull that data in from Google. Now, we probably have 5,000 or so records. And so we can see that it's still running, trying to bring that data in. And we notice that it was pretty slow even just to bring it into the web page. But this should pull that data down. And using the web query wizard, it should just dump it right onto our worksheet. Oh, it's a good question. So what if we get some more responses in now? How do we get those newest responses? And with this approach, we're saying we download the worksheet. So there's no way to say just download the last 10 responses or download the responses after something. Just get the responses. So back here, so now we're here on our data sheet and we're full of data. Now, column A comes out hidden. So that's just one thing to notice. But now, I think we've got the data from the last class. So starting at 230 is when we got to it there. But if we go down, got some wise guys putting in stuff besides ones and zeros. And we should have a few that I put in here, right around 3,600 or so. It had some 8s and 9s, if I remember right. Control, I guess we're almost there. 3,600 is about where it was. Yeah, so there's the 8s and 9s that I was working on. After this, we should see some blank ones where we were trying to insert data through post, but it wasn't working. Anyway, they're there somewhere. Control down arrow. We've got 5,300 different rows here. Some of the data is good, some of the data is not so good. So what I'd like to do is here in the next 15 minutes, I would like to be able to get an estimate of how, if we can see any evidence of bias in the Excel random number generator. So, we got George Washington here making some data. That's delightful. Oh, and here's the blank ones. The governata. Great. Okay. So we kind of need to clean this data up. So let's go ahead and make something that will clean the data. It shouldn't be too bad. Sub clean data. Now, what I want to do is I want to look at the data that was provided, and I want to say should I keep the data, or should I delete the data? Is this row a valid row? I get to a row that's got no entries on it, or it's got something that's non-numeric, or actually anything that's not equal to 1 or 0. I just want to delete it. So anytime I'm deleting data, working through a set of deleting data, it's usually a better choice if my loop starts at the bottom and comes up. Otherwise, if I'm coming down and I delete the row, then the next row that I want has now been pulled up into the row that I'm on. It gets a little more complex. So we're going to work through this data in a way that feels a little bit backwards to us to start. But let's go ahead and get ourselves set up. Dim R as a long integer. Dim C as an integer. And let's go ahead and do this. For R equals some number to what, I wonder? Where does this data end? Control home. The last data is on row 5. So how are we going to find out what row to start on? Well, let's just go all the way to the worksheet and run up until we bump into something in column B. So, let's go ahead and give ourselves a worksheet variable that we can work with. Dim S as a worksheet. set s equal to worksheets named data. For r equals s.cells. Which row do we want to start on? Rows.count, the very bottom one. Which column? Column 1. From there, we want to say end XL up. And we want to ask for the row. Oh, and we're going down to 5, so we got to go backwards. Step -1. So that should start at 5,300, whatever it is, and move up through the data. Now, how can we know if the data are keepers? Let's look across all of our cells. So let's say for C equals, and we want to do column, I guess starting in column D, column 4, and we want to go all the way here to column W. W is number 23. So for C equals 4 to 23. Next. Did you see the movie Monsters, Inc.? Remember kind of at the beginning they have a toxic issue where one of the scarers gets a white sock stuck to his back when he comes back through the door. You have to call in the EPA and they destroy the sock and everything. Do you remember the code that was? We have a 2319. I don't know where my daughter found this out, but she said, Dad, you know where that comes from? I said, no, I have no idea. 2319. It was a white sock, WS. 23 is a W, is the 23rd letter of the alphabet. S is the 19th letter of the alphabet. So 2319 is actually white sock. WS 2319. That must be true. I don't know. It's too crazy of a coincidence to be that. But how she found that out, I don't know. But as a result, I know now that W is the 23rd letter of the alphabet. Okay. Equals 4 to 23. So now I just want to check. So now, right, I've got an outer loop that's going across all my rows. And now I've got an inner loop that's going to go across the columns. I just want to look and see if I've got any bad data in any one of those columns. So I'll make an if statement here. So if s.cells, row number row, column number column, row R1 column, dot value is if it's equal to 1, that's okay. Or if it's equal to 0, that's okay. And so I think we only want to do something if that's not the case. What do we want to do if that's not the case? I want to quit hitting the wrong key. I think we just want to delete the row. S.rows, number row, number R, delete. Now this is pretty good, except for, I think, if I ask if a blank cell's value is equal to 0, I think that's going to give me true. Let me just check. Is a particular cell, I don't think I have anything in A1, equal to 0. Not S, but just my active sheet. That's false. Okay, so maybe not. A1, let me come over here. I'm not sure really what's in A1. I know there's nothing in A1 here. Yeah, so when I compare to a blank cell, it's just like having 0. So I don't want to leave a bunch of zeros in my numbers. So I want to say if it's equal to 0, and greater than an empty cell, greater than empty string, or not equal to an empty string. I'm going to take that whole expression and print it just to make sure that it's behaving the way that I think it should. Okay, so if my active cell is equal 0 and it's not equal to a 0-length string. Oh, I don't have an S. I got to work on my active sheet. Oh, the sheet's right. I just got R and C is not defined. So I got to plug that at 1, 1. Okay, so now that's false. And if I put a 0 into cell A1, it should be true. Good. So now, if I have a blank cell anywhere in my data, if I have anything that's not a 1 or a 0, it should just delete that data. So let's go ahead and run this and see what we end up with. You know what? Good thing to save. And I think I'm going to put a do events in here just in case I've done something hinky. I'm going to put one on each loop. So inside that one, I want to put it just before the next in both cases. It's running and shouldn't take more than a couple of seconds. Now I'm feeling pretty good that I had the do events in there. Let me just pause it and see where it is. What's R? R is only 447? I think it should be going way faster than that. Oh no, it's 447. It's counting down, so it's almost done. So I'll go ahead and print R. Been done by now if I just would let it go. $200. Oh, we're down to the 100s. Double digits. It's pretty good, but I expected this one to go away. Oh, I'm on. That's the Google Sheet. I got to go back to here and look at my data. Looks pretty good. Looks like I've gotten rid of anything that's got a blank or anything that's not 0 or 1. That looks pretty good. Oh, I should have put a formula on this. I guess I'm going to make a separate loop. Actually, maybe I'll just go ahead and put it as a formula. We could write the code to put it through, but I'm just going to go ahead and put it as a formula. I just want a sum here. Just going to sum up my flips. What do I expect? What's my best guess at what that value should be? The sum of my 20 flips, 1s and 0s? Best guess is 10. And you know what? I don't feel too bad about getting a 9 or an 11 or a 12 or an 8. That's I kind of expected right in there. I don't want to see very many 0s. I don't want to see very many 20s. And in fact, I want my 0s and my 20s to be about equally balanced. If this thing is, we've got 5,000 random, chances here, we should expect to see about the same number of 0s as we do 20s. I don't know what we're going to see. Let me go ahead and copy that down. I'm going to copy that and then paste the values just so I can sort it and kind of get a look at it. And we'll sort this alphabetically, or lowest to smallest. Okay, so let's see. I only have my lowest number of heads is 3 heads. If heads is 1. I think that's probably about right. What's the probability of getting all tails or all heads? It's like 0.5 times, no, raised to the number that we have. 0.5 raised to the 20. Oh yeah, that's like a millionth, 1 in a million. Flipping a coin 20 times and have it land on all heads or all tails is like a 1 in a million thing. So the fact is, we don't have any, not a big deal. But we've gotten 3, pretty often. 3, 3, 3, 3, 3. How many 3s do we have? 1, 2, 3, 4, 5. Okay, well, it doesn't look too bad. Oh, we should have more 4s. And we should have more 5s and so forth. Well, that'd be pretty good. I guess what I want to do is, how can I count these? How can I count how many there is of each one? Is that an easy thing to do in Excel? Count if, just make a histogram. Count if would be tough because I got to kind of make the whole if thing. Oh, but you know what? I could make the table easily enough. Let's do that. Histogram might do it as well, but let's just do it this way. 1, 0. Take this down to 20. Equals count if. Just look at column Z. And if it equals 0. Or none where it equals 0. Looks pretty good. And let me go ahead and just make a chart out of this. Insert. Oh, I'm not sure what I did. Go on XY chart for this. What do you think? You see any systematic bias in Excel's random number generator? I'm going to look at that, and I think that looks pretty normal. It's a little more smooth on the right-hand side than the left-hand side. As I look at this, on the 0 side, I don't hit anything until 3. Here, I've got 2 that are all 1s, 2 that are 18. There may be a little bias towards getting a 1 instead of a 0 here. And just the fact that I've got this makes me wonder if somebody fudged the numbers. But otherwise, it looks like pretty good. Yeah, I don't feel too bad about pulling random numbers out of Excel. At least in the range of 1 to 0, looks like it's pretty well distributed. Questions? Ooh, one more thing that I just want to kind of alert you to in the last couple of minutes. So it turns out that anytime we send information over the internet, it goes through lots of people's other servers. And if they were devious and smart, they could look and see all the traffic that's being sent across. In fact, BYU is not connected to the internet. BYU is part of the internet, right? So when we connect up, our servers not only get information for us, but they route other traffic along the way. So how do we protect sensitive information from being visible while it's in transit? What's the word for what we do to it? Yeah, we encrypt it. That's what HTTPS does. So you've got HTTPS. Everything in transit is encrypted. So someone who's snooping along the way can't read it. But in this case, for us to be able to pull this data down, the data has to be publicly available, right? If someone comes across this URL, they can pull this data down, and that might be a problem. And so one approach that we have would be to encrypt the data that we're pushing up there. So instead of pushing gov99 up there, I have the module in there called encrypt, mod encrypt, that has a function called encrypt. I give it 2 arguments, what I want to encrypt, and then I give it a key. Could just be some random number, some random sequence of letters. And that will use that key to encrypt whatever I had there. So that is that encrypted value. I could decrypt it using that same information. So in fact, let me just copy this, plug it here, and instead of looking at D4, I will look at L4, and instead of encrypt, I will decrypt. And that should put it back to what it was. And so using something that can do encryption like this, instead of pushing it up in clear text, I could push it up encrypted so that while it's up there in public, no one can make heads or tails of it. But when I pull it down, I could decrypt it as I'm processing through the data. So even if you say, this information, I'd like to be able to use this approach, but it can't be publicly available, you could still decrypt it so that the part where it is publicly available, unless they have the key and the algorithm, they wouldn't be able to decrypt it. Questions? I copied that function from somewhere. So I've written encryption algorithms before, but unless you're really good at it, they're not. You've got to be really good at encryption to write a good encryptor. And I figured whoever wrote this one was probably better than me. I don't really know how good it is. I copied it from somewhere. All right, thanks for coming. Class dismissed. One more thing here is after I delete the row, there's no reason to keep looking. That's actually pulled another row up there. And so I probably need to get out of this for loop. Exit for. And that should do a little bit better. In fact, it should go faster as well, because as soon as it finds bad data, it quits reading that line.